we ready? Are we on?
Mm-hmm.
Okay, how exciting. Yeah, my name is Tom Baird, and I'm an associate for T-Reps Inc. We are an agent that provides electrical distribution equipment, marketing services, engineering services for several manufacturers. One of those manufacturers is Cooper Power Systems. Cooper Power Systems is the manufacturer that supplied the 2 transformers on a project that we're talking about today. Just to give you a little background on Cooper, I think that's important. Cooper bought a company about 15 years ago called RTE. RTE is the inventor of the pad-mounted transformer and the associated rubber goods and those kinds of supporting elements that you need not only in the transformer arena, mostly medium voltage, but in medium voltage regulators, reclosures, capacitors, substation transformers, a myriad of other products, including the pad-mounted transformers we're talking about today. Transformers in the pad-mount arena are pretty simple to talk about. They have no moving parts. So the questions I usually start off with is, who in the audience has experience either installing, maintaining, maybe gone by and kicked one once in a while, a pad-mounted transformer? At a utility such as this, I would suspect that most of you have had some experience. Yes? Good. And some of you have had no experience. And maybe that's why I'm here.
Yeah.
But anyhow, what's a great thing about a pad-mounted transformer, as you look in your maintenance manual, as I'm showing you here, there's no moving parts, it's completely enclosed, it's actually submersible. How you like that? It is. And so it's very, 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 very safe. Right. The reason why everyone likes the pad-mounted transformer instead of the substation is because of the safety. You have a traffic area, maybe you're in a school, you're out in a park, you're someplace that's not very well protected, the pad-mounted transformer is the answer. So let's take a look and see what we have here. We have a 2,000 kVA, a couple 2,000 kVA transformers, if I recall.
Yeah.
They've been installed since test report. All the transformers have test reports. Test reports are available a few days after the transformer is manufactured and is available to the contractor, the user, the owner, and we try to get it to them within, say, 5 working days. The testing criteria is established by ANSI IEEE. All the manufacturers, whether it be transformers or switchgear, there's some IEEE standard they have to adhere to. There's some code book references, and there's also American Standard Institute. So the whole transformer, switchgear products are very well governed by, most don't know this, NEMA, ANSI, all those guys, those are non-profit organizations. Those are volunteer organizations that take their time. These are usually quality engineers, users, those folks who have a passion to make sure that the products that we provide are safe. You have a very safe product. And really, when you get down to it, most of what we do is about safety. Safety. Be safe, be smart. So here's the test report. The test report will tell me that on, ironically, on March 9th of last year, this transformer was tested. And it passed the test based on the ANSI IEEE standards. So we know that the transformer that's sitting out there is a healthy transformer. It's had its physical, let's say, and it's passed it. And that's why we have the test reports to document that. I think that's important. Let's take a quick look at the drawing. Turn it around the right way, we do that. Take a look at the drawing. This is a final drawing. The final drawing tells you the transformer you have on site is manufactured and has these particular options. it tells you the size of the transformer, and it gives you a little bit of a detail on the options. And this is good to know for me because I can look and see, oh, we have fuses, we have switches. So from a maintenance standpoint, we got to think, you know, what do we need to do to keep an eye on that switch and make sure it's operational? For the most part, nothing. How about fusing? What happens if a fuse goes out? Something we'll cover in a few minutes. We'll discuss how we change a fuse, because really, as I look at this bill of material, the only item in this transformer that could cause an outage is if the fuse opens. And the fuse opens when we have an overload, or something down upstream that's tied into the transformer opens, such as maybe a regulator. No, it wouldn't be any regulators. How about the main switchgear? Of course, the main switchgear opens up, the power to the transformer would shut down. But for the most part, if a transformer stops working, for the most part, it's usually because of a blown fuse. And we'll discuss fuses in about 5 minutes going into this orientation or instruction, or whatever we want to call it. Okay, so we have a final drawing, we have the test report, so we know what we have out there, we know that it's passed the test, we know it's healthy, so now we want to keep it healthy. And the idea of maintenance is keeping your products healthy. Just like a car. You change the oil, you know, every 3, 5, 7,000 miles, change the tires. Well, a transformer, you want to keep it healthy. The good thing about a pad-mounted transformer is there are no tires. There is no engine. There is no moving parts. So it's pretty easy to maintain a transformer. Once it's on the pad, it's been tested, it's been installed, you shut the cabinets, you lock it up with your pentasocket wrench, which I could have taken it out of that plastic, but I don't want to do that because this is the only one I have and no one's getting it. Shut the cabinets, lock the door. Based on your maintenance procedures here, might not open that transformer again for 3 years, 5 years. Generally they last 20, 25 years, no problems whatsoever. Very safe, easy to maintain product. Pad-mounted transformer, a great invention. Okay, what I want to do now is, I'm going to check my notes. My notes say, okay, we already have a pretty good idea of the experience of those in the audience. Some have experience, excuse me, and some do not. And I need some water. I don't know if I had this earlier. Okay.
A question. You didn't actually say what a transformer does.
Good idea. I would have made that assumption, but I shouldn't have. From the audience, the suggestion was to make reference to what a transformer does. Excellent. What a transformer does, it converts one voltage to another. In the simplicity, that's what it does. In this case, we're taking a medium voltage of 12,000 volts, I think. Doesn't matter, 12,000, 12,470. I can look on the drawings, but I'm not going to. But you're going to take a medium voltage. Oh, by the way, what is a medium voltage? Medium voltage is a range of voltages between 2,400 volts and 48,000 volts. And that is a class of transformers called distribution class. Medium voltage distribution class, because they distribute the power to a facility. That's what they do. In lieu of a big utility transformer, which would be a substation transformer that would distribute power to a city. Okay, so very good. Once again, a transformer takes one voltage and converts it to another. Here we're going to go from 12 kV to 48277. Why do we do that? Well, if you look at Ohm's law, it's all about voltage and amps. The higher the voltage, the less amps. It's amps is what we pay for when the utility bill comes in. So if we get that voltage up, we get the amps down. We get the amps down, then we distribute the voltage. We go to motors, let's say with 480 volt. We have a 277 volt leg. We can use that for maybe lighting. Would it be interior lighting, outside lighting, such as light poles, light standards? And then if we do need, and then how do we get the 120 volt? Very good question. The way we get the 120 volt is in the distribution system, such as this trailer, there is a transformer parked someplace inside or outside that goes from 480 volt to 208 120. It's that 120 volt that gives the power to the receptacles and to the lighting in this trailer. That's basically how it starts. Transformer, transformer, lights. I guess I covered it okay. Did I do okay, man? Okay, good. All right, let's see. Who's involved with the maintenance here? Inland Empire Utilities. Is that how we say it? Yeah. I'm going to have to assume that some of the folks here have some general knowledge of a transformer, whether it be a medium voltage transformer or a low voltage transformer. And in most cases, if there is something outside of what I call second echelon maintenance, that would be maintenance that you would do on your car, like change oil in the spark plugs. But if you had to do a valve job, you would bring somebody in. So if you have an issue on any kind of products, generally you go to the manufacturer. They have a team of experts that will come in and take care of that issue. So we're going to talk about just the minimum maintenance and minimum performance, maintenance, attitude of a pad-mounted transformer. It starts with my trusty little book here called S210-12-1. This book is made for most transformer realities that we would have, but here we only have a couple options that we need to go over. One of those would be the switch. If you go out into the transformer and look, it'll be real easy to find the switch. It'll be marked on off switch, and there's a big marking on it. If I took my glasses off, I could still see the switch, and it says on off. You have a device called a hot stick, or I call it a hot stick. Some call it a clamp stick. And it's a device, it's a safety device, where you clamp onto that switch. Oh, here's the key. The transformer needs to be de-energized. You de-energize the switch. This is what I usually do. No, it's a lie. I'm thinking about taps. Cross that out. Can you remove that from that, please? I got taps and switches. Anyhow, the switch, you just take the clamp stick and you turn it off or turn it on. It has a little spring loaded, so it's not hard to do, but it's designed so it's not easy to do. Forces you really to use this clamp stick. If for some reason you have to change the taps, and I didn't mention anything about taps, so now I'm going back and forth, and that's not good. The taps are there so that the voltage fluctuation of 2.5%, you can go in and turn the transformer off, disconnect the transformer. And I mean disconnected from the point source to the transformer and from the transformer itself after you ground the tank, and then you could change the taps. That's in this book, taps. If you look in the book, if you look at the taps, it's on page 14 of the manual. Pretty self-explanatory, it's pretty simple. We talked about the switch. Simple on-off device that you use a clamp stick, turn it on, turn it off. Thing to know, and this is somewhat of a safety issue, is that if you have, the reason why I said initially that if we're going to mess around with the switch, depending upon why if we're going to turn it off, we probably should turn it off. Which means, once again, like you would do with the change of the tap chain, in my opinion, we would make sure the power coming from the main, that switch is open. And then I would remove, in this case, the molded rubber products that attached the cables to it from the transformer. And the reason why I would do that is because when you turn the switch on or off, the power still moves through the bushings. So in this case, I believe we have a loop feed transformer. So to be safe, anytime you're messing around with a medium voltage transformer and you're going to change the taps, work on it, turn it off. Turning the switch off is only part of the procedure, and I know that the electrical code has a detailed procedure of how to make sure that switch is off, or that transformer is off, that the transformer is grounded, and everything is safe. So we're talking about 12,000 volts. So we have a residual voltage on the line, and if you don't go through the procedures that are outlined in an electric code, and some of which are detailed here, you can get zapped. And a 12,000 volt zap is an ugly day. That is going to ruin several days. Okay. All right. Went a little bit back and forth there. Sorry. Okay. Looking at the maintenance manual. I did some highlighting yesterday. This transformer has a pressure relief device. If there's a buildup of pressure in the transformer, the pressure relief device will sense that and open and let the pressure off. The transformers inherently have pressure. There's a pressure vacuum gauge, which will indicate what the pressure is. It's usually slightly positive. It can be negative when you first get it, but generally speaking, it's slightly positive. And if you're looking at a transformer and it's negative and it's been running for a while, you probably have a leak somewhere. We go over that again. You have a pressure vacuum gauge, which should be slightly positive. After the transformer's been running for a bit, hard to tell what a bit is. We'll say a couple days, couple weeks, couple months, and your managers are looking at the transformer. One of the key elements, like when you do your blood pressure, is that the pressure vacuum gauge shows a negative pressure after it's been running for a while. You may have an issue. Probably not a big issue. Because if it was a big issue, the temperature gauge would be in the red. And the alarms would go off because most of the stuff is temperature gauge is usually tied to some alarm contact that warns somebody that the temperature has exceeded its limits. So pressure vacuum gauge, temperature gauge, okay, which is also included in this transformer, or in the two transformers that are here. Oh, good thing about the temperature gauge is that it has two pointers. It has a red pointer, I believe it's red, that the red pointer will always show the maximum temperature that the transformer has emitted. So the red, if it's up here, the temperature of the transformer may be sitting here. This is the red gauge. This would tell me that at some time it got to this point, whatever this point is. So it's a really neat feature. When you look at the gauge, you can also see what the temperature is now, because the ambients are going to create some additional heat. When it gets 100 degrees out here, the transformer may run a little bit hotter, depending upon the load. That can cause it to run hotter. I don't know what you do about harmonics. Probably not big harmonic area here, so that's not going to affect it. But anyhow, the temperature gauge will show you the current temperature of the transformer. It's in the green, and then slightly above that, you may have this red pointer, and that just tells you that at some point in time, that transformer reached that temperature, and that is the maximum temperature recorded for that transformer. I think that's a neat little feature. Got to kind of go out and open the transformer, take the book, look at the operation and maintenance manual, and become familiar with what's in the manual versus what's in the transformer. Good thing to do. Yes, sir.
Is the pressure and temperature gauge available for viewing on the exterior of the transformer?
No.
Okay.
No, that's a good question. We have no exterior temperature gauge. The temperature gauge is actually, I got to think about this before I make this statement. Yeah, the temperature gauge actually, there's a fitting that goes interior to the transformer that's hooked up to some cables, and the cables go to some type of sensing device in the core and coil area, or might sit on, might have on the top of the transformer, the bottom of the transformer, not exactly sure, and it senses the heat from the core and coils usually area, and then that heat is transmitted to the temperature gauge. So that gauge can basically screws on. You can actually take it off if you wanted to. right? But there's no exterior. You could do it, and really in substations, that's not uncommon, because they'll have a control box, and in that control box, they'll have the gauges. But in a pad-mounted transformer, you just have to open up the transformer, and then on the load side of the transformer, if I'm facing it, it'd be on the right-hand side. The left side is the high voltage, or the medium voltage, or the higher of the voltages. And then on the right-hand side is the low voltage, where you have the terminals coming out, and then there's where the gauges are. You have a temp gauge, liquid level gauge, and pressure vacuum gauge. Those are the three common gauges. But that could be done, but it would create some difficulty. But it's a good point, because I know there are utilities. Remember, I'm a C&I guy, so I mean I'm contractor and industrial. But the utilities, they across the country, they all have some special requirements, and I'm sure there's some, and that's a good question, that say, you know, I want a safe and closed box on the side of my transformer, because obviously it would have to be in an area like this that's secure. You can't do it in a park or in an area that has ground traffic. But in a secure area like this, where they didn't want to open up the transformer to check the gauges, it wouldn't be a bad idea to look into the feasibility of having that be an option for a particular secure area like the utility is here. And then you have to weigh the pros and the cons and decide whether or not you want to do it. But that's a good question. I've been for sure people have done that in a secure area. We've gone through, okay, the temperature gauge, pressure vacuum gauge, liquid level gauge, and so those are gauges to give us the readings that tell us the health of the transformer. We mentioned earlier that the major reason why a transformer stops working is because it blows a fuse. Technology over the last few years has done some wonderful things with fusing. In the old days, we had a dry well canister fuse. You don't want any dry well. You do not want any dry well canister fuses. I'm not even going to go into what they do, but those are gone. Now we have what you call a bayonet fuse in series with an ELSP, and that's an energy current limiting fuse. What happens is, if you look at the transformer, if you went out and look at the transformer, on the left side of the transformer, near the top, can be on the right side, the left side, or in the middle. It depends upon the particular construction of that transformer and any other options it might have. You'll find on a three-phase transformer 3 fuse ports. That's where the bayonet fuses are housed. Bayonet fuse is just a little fuse about this size. The ones for this transformer are probably 2 inches longer, a little fatter. There's a little beefier transformer. This is your bayonet fuse. In the instruction manual, on page 9, it talks about switches and protective device. A fuse is a protective device. It protects the transformer. This bayonet fuse protects the transformer from amperages exceeding the full load amp of the transformer. Although that's not entirely true, because usually the transformer fuses are sized higher than the full load amperage of the transformer based on some matrix that I don't get into that. So the fuse basically protects the transformer against an excessive amount of amperage for a period of time, and that period of time we'd have to look at a time current curve, and we're not going to do that today. So what happens is you have a 1000 kVA transformer. I got to think about this a minute. It pulls about 42 amps and 12,000 volts. So let's say theoretically, for some reason, it gets hit with 70 amps for whatever the time is. Half a second, millisecond. This fuse will open. This fuse will blow. That will shut down the transformer. That's the safety factor. That's why we call it switches, and protective device. This is the protective device. This is a protective device that costs $11 to $100. And everyone in this room can change out this fuse with a minimum amount of aggravation. Very simple. And it's safe. Why is it safe? It's 12,000 volts. It just opened. Oh my, I've got 12,000 volts. Well, it's because this device, same one I showed on the transformer, upper right hand side of the left section of the transformer, which we call the high voltage side, is a load break device. What does that mean? Well, the utilities, we're talking about Southern Cal Edison, Riverside Utilities, any utility in the country, they actually use the bayonet fuse as their switch. Many of the utilities have no switches. If they want to turn the transformer off, they pull the fuse. They pull the fuse. Because it's a load break, it means it's safe. So what you do is you get a hot stick or a clamp stick, however you want to call it. All you have to do is give that thing a half a turn to unlock it, grab that clamp stick, quickly pull it out, and you'll be looking at, if you look on page 11, actually on page 10 and 11 of the maintenance book, once again it's the S210-12 that's 1. You look on pages 10, 11, and probably 12. And 12, the illustrations are simple, easy to understand, and believe it or not, when you go to do it, it's that easy. I've done a few myself. Going years back in Florida, I was in Florida, it was like 100 degrees out, I did about 30 of these. And after the first one, I was as good as any electrician, because you're a little bit scared of the first one. Then you go, oh shoot, that was pretty simple. And then you replace the fuse, okay, and do the reverse procedures. If you go throw the bayonet cartridge fuse back into the transformer, and if there is a problem with the transformer, it just blows again. Oh, well, that's scary. No, it's not scary. It's a load break device. Nothing to be scared about. In fact, these bayonet fuse holders, called a draw-out fuse holder, I think, even have a little valve, a flapper valve they call it. So when you pull it out, there's a minimum amount of oil that comes out with the fuse holder. So it's an ingenious device, simple device. And in a very short period of time, one can become very proficient, like by the second fuse. Okay. The Girl Scouts could do this if they had the strength. You gotta have a hot stick, gotta have a man or a woman with a little bit of strength to do it, but pretty easy stuff. The transformer that I ship generally come with spare fuses. There's a spare fuse, may not show on the drawing, but there's a spare fuse pocket I wouldn't show. But on the door of the transformer, when you open up the door of the transformer, there's a little pocket where you'll find the a copy of the maintenance installation and maintenance manual. Used to be called operation and maintenance. Now they call it installation and maintenance manual. And you'll find a little pocket. In that pocket, you'll find your spare fuses. One suggestion I would have is that make sure you have spare fuses for all the transformers out here. And make sure the transformer, that the fuse has an ID on it, tells you where the transformer is located. If it has a specific tag for the transformer, that like transformer 1, and the fuses associated with that, and the catalog number of that fuse written on the box or on the freezer bag or whatever you want to put them in. I use a lot of freezer bags, and I type myself some notes, and I stick them in the freezer bag, and I put my stuff in it. And these fuses that I stock, a few of, are all in freezer bags, with some general information, which is good to do. So we have any questions on fusing? No? How are we doing so far? Okay, thank you. I'm going to take a second here and just go over. Oh, I bet that every truck has at least one pentasocket wrench or a ratchet type. I have a lot of ratchet ones too, but these are kind of neat. I could have brought a ratchet, but I left it here. I forgot. All right, so we talked about switches, we talked about cages, we talked about safety a bit. We'll get a little bit more into that as we close. Really, you know, there's no moving parts, so we got switch, fuses, and gauges, and a door, and a wrench to close the door, and a hot stick, which you would need also. That's basically it. Pretty simple device. Let's see what else I have going here. Oh yeah, here we go. Well, backtracking, which I do a bit of. On us, actually it says close, open, so pretty simple. Grab a hold of it, open, close it. That's on page 13. What I know about switches are on page 13. I'm going to review where the pertinent items are as I close. It's good, I guess, on an annual basis, but I think in the real world, every 3 or 4 years, and some places it might be more or less. I'm sure that they have their own maintenance program here that dictates how often the equipment, including transformers, are serviced. Well, service on a transformer is really not the proper term. I guess looked at. We would look at the gauges, open up the transformer, see if there's any critters got in there, which is doubtful. Every 5 years, maybe do an oil sample. But there's stuff in the code book, and then there's recommendations in this maintenance manual to what they suggest you should do. But a place like this, big utility, I'm sure they have a pretty defined maintenance protocol. Yes. Let's see, we don't care about that. Okay. It does talk about on page 26 sampling of the liquid, and you'd have to read through that. You basically refer to ASTM standard that you can get online. I'm sure they have it here in their books. It tells you how to run a sample of the oil, which you should do about every, in my opinion, 3 to 5 years, but that's just my opinion.
Can you just briefly comment on the cooling medium?
Yeah, I'm going to, about the oil?
Yeah, just what is it?
Yep, I'm going to do that. Very good. So we talked about the transformer. We made a lot of mention to oil. The typical oil that was in most of the transformers, provided in the transformers over the last 100 years, is a mineral oil. Mineral oil, of course, is a oil-based, fossil fuel, carbon-based, pretty common insulating material that has a flash point of about 140 degrees C. About